I think I've pressed it. Yes, I have. So, welcome
Are
everyone
you
to the
sure this time, DPR?
That was repetition.
welcome everyone to the after show, Magic Sandwich Show 110. We thought it was an incredibly good conversation that we were having. So let's carry on with it. Who wants to pick up with what was going on before?
I had a question for Professor Moriarty. When we were speaking earlier, and we were talking about Watson and some of the comments he made about race and IQ and that sort of thing, you were saying, sure, I mean, he has a right to say it, but he has to pay. You might have to suffer some consequences. And if you're going to say something like that, you better have excellent evidence. You used initially you used the word incontrovertible, but I know you didn't mean literally incontrovertible. You meant, but you need a very high. You have to meet a very high evidentiary standard. The burden of justification here is very high, and I want to take exception to that because it seems to me that if we do that with certain socially and politically sensitive topics, what we run the risk of making some subjects into a kind of intellectual pornography, where we're not allowed to talk about them, where we risk extraordinary social censure, possibly career-destroying social and censure and professional censure, and consequently, a question can never get answered, can never get investigated because it's treated like intellectual pornography. If you even broach the subject and say, oh, "This is what I want to study. I want to study." In differences in intelligence between races or between the sexes and stuff like that, you're immediately going to have people descend upon you with allegations of racism, sexism, or whatever else, impugn your motives, attack your character, and insist prematurely before the investigation is even underway that you provide proof that this is the case. And this just seems to me anathema to scientific investigation.
Okay.
And I understand why politically people want to do this, but it just seems to me that from the standpoint of science, we can't tolerate this. We have to be open and let people investigate and explore these ideas.
Very good, extremely good points. I agree with. So I mentioned I was part of our diversity committee. So I'll be brutally honest here. So there's been quite a lot of discussion, and also in the Times Higher Education a couple of weeks ago about bringing religion within the diversity agenda and making sure, diversity agenda, that's awful jargon, but bringing it within a sort of diversity equality, making sure that you have deep respect for those beliefs. That's something that causes me a great deal of discomfort for exactly the reasons you had, and it's led to lots of debate back and forth. I'll send you a link to a blog post which I wrote about this. I was brought up an Irish Catholic. With all that entails, I sort of didn't believe in God from about age 9, but had to suffer Catholicism for a lot longer. So religion is a real, to use Thunder's term, trigger word for me. So I can absolutely see what you're saying. My point, and I agree, it just like incontrovertible, needs a little bit of explanation and padding out, is in terms of Watson's position. What I was trying to do is to draw an analogy with Hunt. Watson is a Nobel laureate. Okay, so that means he has a certain standing in the community. And it's particularly with broadsheets, tabloids, with media in general, they will take a Nobel laureate's words and effectively the undercurrent, the under-argument is, well, this is a very clever guy and he thinks this, therefore there must be something in it. It was in that context that I was saying that if he's going to make it's basically if you're going to make extraordinary claims, you better have extraordinary evidence. That was my point.
But isn't an extraordinary claim?
I have to come back to the prof Phil.
Mm-hmm.
I find that expression, and I know it's used by many people.
I know.
I find it so irritating. Exceptional claims require exceptional evidence. I'm sorry.
Well, that's fine. And mediocre claims require mediocre evidence.
I'm a lawyer, and I do not understand what exceptional evidence is.
Well, I never understood what reasonable doubt is.
Well, in that case, it's a good
touche.
It's a good job you've never sat on a jury. Then
I have.
Yeah,
I still don't.
I'm sorry. What is exceptional evidence? I simply do not understand what evidence. Evidence is evidence.
No. DPR. Let me explain. If you wanted to claim that the Earth was a cube, right? You can claim that, but in order to actually be taken seriously like that, you would have to provide some pretty substantial evidence.
Yes,
to prove that the Earth was actually a cube.
I totally agree, Thunder. You would have to provide evidence, but would it be exceptional, extraordinary,
Yes, it would,
whatever?
because it would have to
I don't
confirm.
understand. My criticism is, and I'm sorry to distract from the conversation, I simply do not understand what extraordinary evidence is. It's
Because
like
I-
it fits
I-
into a different level of.
No, I can agree with Thunder here. I agree with Thunder because what you say, what you have to do in that cube. Yeah, I can. On this particular case, I'm going to agree entirely with Thunder because it's exactly that. If you were to claim that the Earth is a cube, you can make that claim. But what you've then got to do is overturn centuries and centuries and centuries of evidence.
That's been
So
done.
you-
though.
It's
been done. You've all seen Time
I'm going to
Cube.
cut that clip and have it.
Is it good?
As my sort of like phone message, whatever. I agree with
Ringtone.
Thunderfoot. I never thought I'd hear those words, but there we
But
go.
come on, this isn't controversial, DPL. We agree on lots of things. We agree on Newtonian physics. We agree on quantum mechanics. We agree on lots of things. It's not
Nobody agrees
controversial.
on quantum mechanics.
Absolutely,
Nobody
and
agrees.
that is a very useful segue into our next topic, which is something that
Jesus.
Ozzy. No, please. Ozzy wanted to raise. I had a question, and because we had a professor of physics on the show, I wanted to talk about science and physics and everything. We haven't had that opportunity. I had a question, but I'm gonna hand over to Ozzy for this one. But
Okay.
I may come back to my question. Ozzy, you had a question about physics that you wanted to ask, and Ozzy, can I just remind you, keep it down to 1 minute.
Sure. Okay.
Clock's
I don't know.
ticking, dude.
I don't know what your area of specialty is, but I'm really curious about a set of experiments having to do with quantum physics that is mind-boggling. Everyone knows about the famous two-slit experiments and the various interpretations, the Copenhagen interpretation, and so forth. But I'm in dialogue with some people who have certain ideas, idealist ideas, idealist interpretations of quantum mechanics.
30 seconds to go.
And they specifically they invoke the delayed choice quantum eraser experiments. And I would like to know what your opinion is on those and how you interpret those findings.
So this is a question of this is a really fascinating question. So the delayed choice experiment is where you make effectively you delay your choice in terms of the slit and see how that actually affects the outcome of the experiment. And what it seems to be very much pointing towards is the central role that information plays in our understanding the universe. Not energy, not matter. The fundamental quantity appears to be information. And that's the message I take from the quantum eraser. For me, quantum mechanics, there is a huge gap in our understanding. When we take entangled particles, so particles that you can put in a particular state, and I think I've mentioned this before, the DPR, send one to one end of the universe, other to the other end of the universe, make a measurement on one, and the other one responds or is coupled instantaneously, not at the speed of light, instantaneously. There are major deficiencies, and I put it akin to where we were at the start of the 20th century with the ether. There were major deficiencies how we understand things. There are people like Sean Carroll, who's a great scientist, great writer, who very much fall down in sort of the many worlds theory. I have lots of difficulties with many worlds, largely in terms of testability. The issues for me, I'm a dyed-in-the-wool experimentalist, and the problem is you need to again back up your theoretical claims with experiment, and sometimes that doesn't happen. But coming back to the delayed choice, that does seem to point very heavily towards that a key aspect of this is information. And then because quantum is fundamentally a theory of probabilities, it's about limiting our choices in that sort of probability space. And so I'm not a quantum theorist as such. I'm what's now called a nanoscientist. 20 years ago would have been called a surface scientist. We do we do experiments on single atoms, single molecules. What we do is, you mentioned the Copenhagen interpretation. In that sense, we collapse the wave function every single day. And I know that's not a particularly satisfactory answer to your question, but I think what it's pointing towards is really, the central importance of information and our state of knowledge of a system. And then the problem is that
Let me ask you a question that's maybe more attached. Do you think the universe is deterministic? That if you knew everything, you would know what will happen next?
No, because even classically, leaving quantum to one side, which is fundamentally a probabilistic theory, at least, we could argue that there are hidden variables there. Compatriot of mine, a guy called John Bell, had a set of theorems, inequalities, which, at least in a range of different senses, shows that really there aren't hidden variables there. Sort of quantum is sort of what it, says on the tin, as it were. I'm starting to get around to answers which are getting towards Aussie proportions. Let me backtrack a bit. So in terms of determinism, no, because you can have classical systems which are not deterministic, like chaotic systems. So the Laplacian view of the clockwork universe, no, doesn't hold, and you don't even have to invoke quantum for that.
So it's like timey-wimey, spacey-wacy.
Well, no, to be fair, quantum's timey-wimey spacey, but classical chaos is not so much time. It just means you've got a system which is exceptionally sensitive to the initial conditions.
Yeah, it's all on top of the perfect sphere, yeah? Which way is it going to fall off?
Kind of. And again, you could look at that from a quantum point of view in terms of 0-point energy, etc. But it's more to do about a system being driven, basically following exponentially different trajectories depending on very, very small changes on its input. So it's like a cascade.
But if initial conditions are ultimately determinate, that's still a deterministic universe, right?
No, because the system. So okay,
it's determinable, is what I mean. It would be determinable ahead of time if you had, if you were Laplace's demon, if you knew, if you had the infinite amount of information,
which you can never have. This is the problem.
But maybe we can't have it. But the idea is in principle, right?
Okay. Well, this is where a physicist and a philosopher will disagree. So I'm a physicist. I'm an experimentalist. What matters to me? So, for example, a really good example of this is like the Brian Cox thing about Pauli exclusion. I don't know if you remember this a few years ago, where it was talking about that if you rub a diamond here, the electrons and Alpha Centauri will be affected. Right. So that's a very interesting idea. Theoretically, truly, if you're going to take quantum mechanics, then yes, my electrons are coupled to your electrons and DPR's electrons and to electrons on Alpha Centauri.
You pervert! Stop affecting my electrons!
Calm down, Thunder, calm down.
You didn't ask my permission!
Stop it. And so in that sense, theoretically, we have to think about a universal wave function. And the problem with that is then that gives rise to all the type of stuff that Deepak Chopra et al. Trot out about everything being holistic. However,
if I recall, Phil, I'm sorry to interrupt you. I watched the lecture that Brian Cox made, and I recall the specific example that you just referred to. And he was heavily criticised for suggesting that, when he rubbed this, something was happening on the other side of the universe.
He was. But
in some theory, it sort of like works, but in practicality, I don't know.
You're absolutely right. In practicality, I'll get to. I've had a number of email exchanges with Brian about this, and he's a clever guy, Brian, and so too is his collaborator Jeff Forshaw. And they've thought very deeply about this. And the problem is, of course, he's pitching it. It's exactly the situation we find ourselves in with 60 Symbols. You're pitching it to a wide audience. It's not like you're doing a lecture, or it's not like you're doing a conference presentation. And therefore, you cut corners. You always cut corners. You just can't avoid it. But
absolutely,
in quantum, we, in principle, have to think about the entire universal wave function. However, in practice, the energy differences, the coupling between my electrons and let alone your electrons, DPR, or even between these two objects which are spaced by a centimeter, is so absolutely, unbelievably, negligibly small, and I am
dramatically. Newtonian mechanics works.
It just doesn't. It's something that isn't there. Yet in the theory, in principle, we have to take that into account. Indeed, the Feynman version of quantum mechanics, a mathematical tool that Feynman developed, means that if we have a photon of light traveling through glass, to go back to your discussion of transparency of glass right at the start, not only do we have to consider the paths through the glass, we have to consider every single possibility, every single possible path for that photon, including the ones that go out to Alpha Centauri and back again. They might have a negligible contribution, but quantum mechanics tells us we have to include them. It's mad.
But I mean, this is the thing, you know, you said earlier you're an experimentalist, and I'm all up for that. And, you know, in the experimentalism, you do this all the time, that there are all sorts of things that are in principle relevant, but in reality they're not. They're parts per thousand. They don't even enter onto the measurement.
Yeah, so in terms of the electrons here and here being coupled, let's say that's a centimeter apart. It's not parts per thousand, it's parts in
Parts per billion.
10 to the minus 80. So it's just so negligible as to be completely, utterly, you know, there's like 10 to the 82 protons in the universe, something like that. So it's such an incredibly, incredibly, incredibly small number. Yet, this is what really frustrates me about Deepak Chopra and his ilk, is that they will take this, and we are guilty to some extent for helping them do this. They will take all the weird and wacky stuff that happens at that small level, that microscopic, nanoscopic level, and just extrapolate it out to say that, well, me and you are coupled at some level. It's really frustrating. But we are to blame. Physicists are to blame to a certain extent.
I don't see how physicists are to blame for that. It just seems to me that you have people, charlatans like Deepak Chopra, that are exploiting the scientific ignorance of people. And I think that physicists have, like all scientists, have a responsibility to do some kind of outreach and try to make what they know accessible to the extent that their talents permit them to. Not everyone is so gifted, but you know, not everyone can be a Stephen Jay Gould or Carl Sagan or anything like that. But it just seems to me that the fault has to be laying at the doorstep of these charlatans who understand the stuff just well enough to be able to bamboozle people who don't understand the stuff at all.
No. I disagree completely. I mean, this goes back to what we were talking about earlier. I mean, the number of people who can actually understand this is basically zero. I mean, when you're talking about quantum mechanics, you know, Feynman had this thing, you know, that basically the whole thing's a set of mathematical expressions. To say that you actually know what it means is almost a statement.
I don't mean that you understand all the implications. I don't mean that one understands all the implications. I mean that Deepak Chopra is intelligent enough to understand that phenomena that are expressed only at that level of description and analysis are not phenomena that are present at a higher level of description, at the level of ordinary objects. He knows that this is not to be found there. The evidence is not there. But what he tries to imply is that because there's all this queer stuff happening that looks virtually like magic and mind over matter at some lower level of description, that this implies that you can just sort of, you know, bring things about in your life by willing them and stuff like that, right? This is what gives rise to New Age twaddle like The Secret and stuff like that, right?
But if you take a look at the markets for things like the New Age twaddle, they are I wouldn't be able to give you an accurate number, but I would guess that the market for that is probably comparable to the funding for universities. I mean, Phil, give me an estimate on that. Yeah, just an off the top of your head estimate of the
talking about $1 billion. I guess, in terms of research, let's think of Research Council budget. So EPSRC is about $1 billion per year.
Right.
Would Deepak Chopra's crystal field bollocks and all that?
But I'm sure homeopathy.
You told it all up. I think you're probably right. Right.
So looked at like this. I mean, this would be one of my criticisms of academia at the moment. Is it really does have this sort of nice and clean image of but we're just going to do the educational stuff and so forth. But you know, really, no, you've got to go and tackle this pseudoscience bullshit, which is actually undermining the credibility of the real scientists.
Exactly. That's exactly it. Yeah, and we do try to counter that. But in terms of where Ozzy says we're not culpable, we sort of are culpable. So if for example, if we're doing any of my colleagues are doing a video for on quantum for 60 Symbols or any of the other channels, you do play up, isn't this amazing, isn't this wacky, isn't this weird? Right. Because at that level it is. and sometimes the provisos are lost. And I think we have to take a little bit of the blame for that. On the other hand, it's a real dichotomy, because what you don't want to do is get into all the tedious detail of here's how you write down a wave function, here's how you do the integrals, here's what a matrix element is. Obviously, that's not going to work. So you've got to try and balance up rigor and, how can I put it? Well, let's just say
There
rigor.
are compromises to be made.
Sorry?
There are compromises to be made.
There are indeed, yeah. So that's a three, yeah. That's a good way of putting it. I just noticed. I'm following the Vaughan set of comments as they come up here. You can see it's getting close to midnight, so I can't construct sentences. But one question that's come up, which is great, is I say in that glass is transparent thing that glass isn't a liquid. Were you taught this, that glass was a liquid?
I was.
I had been, and then unlearned it several years ago.
It's a disorder.
I was curious about that myself. How does that get around? Who thought of that? What does that mean? Why?
So it's to do with many people found that in terms of stained glass windows and various different glass windows from centuries ago, they seem to be a bit thicker at the bottom than the top, which was just a function of the glass blowing process and just a function of how the window was made. And yet that was interpreted to think that glass was a really slow flowing liquid. In principle, it's a really slow flowing liquid, in that it takes time scales, so the appropriate time scale to consider is about 10 times the age of the universe. So in that sense, it's a slow-flowing liquid, but in all realistic senses, it's a solid.
Okay, well then what's a liquid?
So a
liquid, right? The difference is, right, you've got thermodynamic stable states. So you've got things like crystals and liquids. And a glass is basically something that looks like a liquid but hasn't found its way to a crystal yet. There is a thermodynamically stable state beneath it, but it takes it an inordinate amount of time to actually get to that state.
Yeah.
That does sound like it had. That does sound like it is a slow liquid, though. When couched that way, it really does sound like it's just a slow liquid.
Well, but it depends on what your time scale is. You're willing to wait 10 times the age of the universe. Then, on any realistic time scale, it's a solid.
Yeah, I think people are fishing for the qualitative difference, and you appear to be pitching a quantitative difference.
Yeah.
So the only difference is how long you want to watch it. I don't.
Yeah, I mean, but this is where, if you're a scientist, things like thermodynamics, you really do start to see the universe in terms of two aspects, which is basically the thermodynamics and the kinetics. And glasses are thermodynamically not stable states.
Absolutely. Similarly with diamond, we wait long enough and little black flecks will appear in diamond, because the thermodynamically stable state of diamond, of carbon, is actually graphite. That's where it wants to get towards. So you could argue that there's absolutely zero difference between diamond and graphite. It's just that it's where you've trapped them kinetically, as Thunderfoot is saying. So not very many people.
Kinetically, another term that no one will understand. Yes.
Not very many people would say that diamond and graphite are exactly the same thing, given that one's transparent and shiny and one's black.
I want to throw in another one. I'm terribly sorry. There was a question about quantums. I'll leave that for a future date. I hope I'm going to be able to share a screen with you. I know that Thunder has addressed this, but hey, we talked a few years ago. I subscribe to Answers in Genesis, and they send me emails every so often. And one of their most recent ones concerned the fact that we're going to have an additional second in June. Okay? And...
second?
A second. What? Yeah.
June.
We're going to have a second, and I'm hoping that... Yep, there we go. So if you're watching on Vaughan, this is the Answers in Genesis post, and I'll be able to scroll down.
For me, sorry, all I can see is the comments feed. The video and I've tried to restart and set it up. I just cannot see the video.
That's okay. I'll read it out for you. How will you use your extra second at the end of this month? This is from Answers in Genesis, and it basically, as you could imagine, says that hey, how does this happen? And I want to go to a specific point here. It says, direct computation shows that the Earth and the Moon would have been in contact 1.3 billion years ago. Now, Thunder, I think you did a video about this, many years ago. Creationist nonsense about how... Oh, hang on a second.
And Phil can probably do this as well as I. But it's basically the Earth spins faster than the Moon goes around it, which is a bit of a bizarre situation in the solar system. What tends to happen is you get these, what are they called? Tidally locked structures, which is basically the body in the center rotates at the same speed the Moon goes around it. Now, the Earth and the Moon aren't tidally locked. That is, the Earth spins much faster than the Moon goes around the Earth. And the reason that the Earth is slowing down and the Moon is falling upwards are the same. And that's that there is basically energy being transferred from the Earth's spin to the Moon's orbit. And that's mostly done, and Phil can correct me if I'm wrong on this, but the way that I understand it, the majority of the way that that's done is actually through the water on the Earth.
Absolutely.
That 6 feet of tide on the Earth is actually a very big component in transferring energy from the Earth to the Moon. And therefore, the actual positions of the tides on the Earth make a big difference in how you're transferring energy from the Earth to the Moon. And
how does the water do it? Sorry, is the slosh of the water? Is that it?
Pretty much, yeah.
Oh.
So it turns out
why you've explained it before. DPR has asked before, and I'll tell you why we always have trouble. We being the layman always have trouble understanding it. What do you mean when you say energy is transferred to the Moon? Because normally when you need to transfer energy from place to place, I have a USB cable here to transfer energy from my computer to my phone. We have oil pipelines to transfer energy that's collected in the oil fields to the refineries.
It's transferred. It's a physical concept. It's in terms of the gravitational field.
Yeah.
So that's
okay.
That's it. You got to think about it in terms of that. It is a tricky concept. What's that? I can't see. Hang on. Okay. Yeah, no, in the key, pretty well Thunder's got it spot on there. It's a question of the Earth rotation slowing down, and that is largely due to the interactions between, certainly a component of it. So I'm not an astronomer, I must admit. We really need an astronomer in this case. But certainly a big component of it is exactly as Thunder's described it, is to do largely related to the tides. And it's basically like a dissipative effect. It's where you've almost got a frictional effect where you're leaking energy out of the system. So it's that's really the base of it. So what was in terms of answers in Genesis, which I've not come across almost before, what was their beef with the 1 second then, DPR?
Basically their suggestion was that 1.3 billion years ago, the Earth and the Moon were going to be in close contact. If you give
this is a classical creationist canard.
Classical creationist argument.
Yeah,
and
the answer is bollocks. Is you just do the linear extrapolation,
and
work out that it's only halfway, right? And that's the linear extrapolation. I think that it actually goes to the power of the 6th or something, but I'm absolutely certain that no creationist ever did those calculations. But the bottom line is if you go through the expected trajectory, the Moon is only half the distance that it currently is.
Okay, I really need to look up the creationist view on this, because I haven't come across this before. Because I try to avoid as much as possible getting into long and lengthy, pointless debates with creationists. I have immense respect for you, Thunder, for doing that and for your video series on that. But
okay, I fully accept your irritation with creationist arguments. One thing I will ask though, and it's a question I wanted to ask from the get-go. and it goes back to quantum physics. It goes back to the nature of the electron, whether it's a particle or whether it's a wave, and it goes back specifically to how Schrodinger's cat. Okay, now I think I have an understanding of what's going on with his thought experiment. But what I don't understand is this. And
Schrodinger never fed his cat. That's why he never had one. Sorry. Okay.
Okay. But I'll put it in very simple terms first. And if you don't understand my question, then I'll explain it in more detail. But why does the observer have to be a human? Do you understand what I mean by that?
Yes. No, I'm delighted you actually asked me that question. The observer does not have to be a human. This is another aspect of Deepak Chopra bollocks. The observer can be anything that interacts with the system. So a stone can be observer. Air molecules can be an observer.
But they're typically macroscopic, yeah?
But, okay, I'm so glad that you provided that answer. And perhaps I need to express why I'm so glad about it, because I've considered Schrodinger's cat for a long time, and as I say, I didn't understand why there had to be a human behind it. But the fact that you've explained it so definitively makes me think, well, perhaps I'm not a genius. I've just misunderstood it. There is a collapse of the wave function in Schrodinger's box that is triggered by a Geiger counter or whatever, and it doesn't require human.
No, this is a real problem. You don't need a human observer. You do not need a consciousness. Okay. However, where it does get thorny, and this is, I would say, still an unresolved question, is the question of information and information transfer, etc., etc. When we talked about that delayed choice experiment some time ago. However, when it comes, there is definitive evidence that you don't need a conscious observer. You can collapse the wave function when the quantum object interacts with its environment. And what causes that collapse? What causes you to move to a particular, instead of having this whole sea of probabilities, how do you collapse down, to use the Copenhagen interpretation, to one particular? It's because the waves get scattered, those electron waves, those particle waves. If you think about just waves sloshing up and down on a surface, or sloshing up and down at the beach, and you have stones and you have rocks, they will disrupt those waves, and in physicist terms we say that they decohere. They lose the relationship with each other. They move out of phase with each other. They move out of step with each other. And it's at that point, that decoherence effect, that gives rise to the collapse of the wave function. And that can happen not through an observer, but a conscious observer, but through just a measurement.
Yeah, any detecting device, an inanimate detecting device.
Exactly.
But this is what's weird, though, because with the delayed choice quantum experiments, precisely what we find there, if I understand those experiments, is that the relevant variable here is knowledge or information or knowledge about the which path, right? It's the which path information specifically that is the determinant that allows you to know which slit the entangled particle went through. But so that's not to speak of to say that it's knowledge of the which path information that is the relevant variable, that is the determining factor, is precisely to say that it's not going to be an inanimate object. Presumably, an inanimate object can't possess a knowledge of the which path information.
But, no, this is again a great point, Ozzy. And in this case, I certainly do not have a definitive answer to this one, and I think this is certainly very much an open question. as to how exactly do we define information in this particular case, and does it need to be a conscious registration, or does it just need to be some interaction with some part of the apparatus that distinguishes it from some part of the other, that gives rise to something, to some interaction or some effect that can conceivably be measured. That sounds like an awfully long-winded and awfully roundabout way of explaining it, and the reasons for that is because I still don't think I don't think it's the case that we have not got to the bottom of this. However, in terms of collapsing the wave function, if we are talking about the Schrodinger cat and experiment and the Gedanken experiment, and Thunder raised this when he talks about macroscopic, it is clearly the case that you do not, to collapse the wave function, you do not, if we put the quantum eraser to one side, delayed choice to one side, you do not, in a large number of cases, need a conscious observer to collapse the wave function. So there is a dichotomy there. The delayed choice experiment is a fascinating experiment, and I think raises very many issues for fundamental quantum mechanics.
My understanding of where it's at, sort of where some people get confused on it. Where the case was first presented to me, it was actually presented as the Schrodinger's cat paradox, right? In this idea that we can talk about these subatomic particles which are unfamiliar to us as being in not this state nor that state, but actually both or whatever, some wave function thing. Okay, whatever, that's all heady, that's fine. But once you start to apply it to this cat, is this cat alive or is it dead? Well, not really. Well, yes, both. You know, is it once you start talking about macroscopic objects in that sense, how can the cat be both? And that's so it was always introduced to me as a paradox. And the thing about I want to make one quick point about the conscious observer thing. Is it let's keep in mind, and not to pigeonhole Ozzy, but Ozzy often speaks based on his education towards issues related to philosophy, including philosophy of mind and epistemology. So Philip, when you use words like knowledge and information, they carry not your baggage, but his baggage, right? So, a type of knowledge is a type of a belief. It's a justified true belief and specific justification for it. He can expound on that. But for there to be a belief, there has to be a believer. For there to be knowledge, there has to be a knower. For there to be information, there has to be an informer and an informed. So I think that's partly why we get tangled up in this idea about there needs to be thinking conscious beings. My understanding, though, by the way, is that the cat would be the first. So the cat would be the first living creature to be aware as to whether or not there was a decay.
I don't see it like that. So the whole point of I absolutely take your point about knowledge, knowing, information. Let's put information to one side, because I see that sort of a separate in terms of knowledge and belief, and there's information. I do not roll information into the same pot as knowledge and belief, perhaps strangely, but I'll get back to that in a second. With the Schrodinger's cat experiment, remember that it was a Gedanken experiment, and Schrodinger set it up to demonstrate the ludicrousness nature of some of the claims being made by quantum physicists, including the fact that the cat would be in this mixed live dead state. So the important thing is that is the question of coupling the state of that decaying atom to a macroscopic system, and then to a large scale system, because of course we know at the atomic level and the electronic, the particle level, we've got these wave-like properties. Okay. And again, those are just wave-like. It's not like the electron is a wave. It has wave-like characteristics. But when we get to our size, we don't diffract when we go through a door. We don't have wave-like characteristics. So clearly, and there's something called the correspondence principle, which we drum into our students in first year. So Ozzy, you're on the philosophy side. So you'll have come across Kuhn, yeah?
Yeah, sure. Right. Yeah, Thomas Kuhn, yeah.
Yeah, so in terms of scientific revolutions and paradigm shifts and all that, I really have a big problem with a lot of what Kuhn said, particularly where he talks about these sort of lack of correspondence between different paradigms like classical physics and quantum physics. We spent so much time in our first year and our second year and our third year teaching students that you've got to consider these in the right limit. So if you've got a quantum system in the right limit, it's got to behave like a classical system. If you've got a relativistic system, if you slow things down, it's got to behave like a classical system. So there are this continuum. However, the key difference, as it's understood now, and I'm not trying to say that quantum is set in stone, it is definitely not. There are many opinions on this, but the one that's in the lead at the moment is the reason you don't see these quantum effects on a macroscopic scale is because you scatter those electron waves. They interact with their environment. You lose all the relationship, the phase relationship between them, and that's why you end up with these objects that don't have wave-like characteristics. The thing with the Schrodinger cat is that's such a large object. It's got all these various different, if you think about all the atoms, all the electrons in that cat, they're interacting with its environment. They're standing in a box. All the atoms in that box are shaking. All the atoms in the air are shaking. Those electron waves, those probability waves are getting scrambled, and that's what collapses the wave function. Did that make
Just
sense?
real quick.
Let me just add something.
Sorry, can I just interject? Because I do have to leave, so I apologize, Thunderfoot. But I wanted to mention too. Please don't allow me to pigeonhole Ozzy. While I mention his experience in philosophy, please. He's a very, very bright guy. He knows a lot more about science than one would not expect from. No offense to people who took philosophy, but someone who took philosophy. Was there a compliment in there? When I started talking, it was going to be a compliment. I think
it was kind of a compliment. Yeah.
I'm sorry. I don't know where that was.
Ozzy's
it's a
a
compliment.
bright guy despite
Ozzy,
his knowledge of philosophy.
No, it's a compliment, Ozzy. Pipe down.
Yeah.
I'm so rude and offensive. I'm sorry. Go on, Hogtie.
Well, that one was an accident. I admit I was trolling Philip before. That was an honest troll at the end of the show. I get that, but that was an accident. But I thank you guys. If I don't mind, I'm going to excuse myself. As I mentioned before, my mother-in-law is visiting. We're going to do some fun family things. Great honor to meet you, Philip, and I hope we bump into each other again. And thanks all.
Been brilliant. Great to meet you, Hogtie. See ya.
Yeah, well, let me take this opportunity to say goodbye as well. Actually, I have to go. Supper's on, but this has been a real pleasure to talk to you and to meet you this way. I'll recommend the channels that you participate in, 60 Symbols and Numberphile. Those are the only two that I'm familiar with that you participate in. But I've learned a lot in a little time from watching them. And as we were saying before we went on air, one of the things that I like about that is that these shows, these videos that you do, are not sort of scripted like a sort of a Carl Sagan moment or something like that. We get to hear scientists and mathematicians talking out an idea. They know what they want to talk about, but then one person will interrogate the other and ask a question, and the question goes off, and the answer goes off in a direction that was not anticipated by the person who was participating in the video, be it you or somebody else. And consequently, one has the satisfaction of seeing a scientific mind, the creativity of a scientific mind in operation. One gets to see a scientist in the act of thinking, and that's really very different. You get to hear science being thought out, and it's very different from a lot of the science content that one finds in YouTube videos. So I recommend those channels to everybody who's listening.
One thing I was going to say, I really hope we can get back in a future date. So one thing I've suggested to Brady is something we could do for a future topic. It's been 6 or 7 months since I've done one, so I'd quite like to do another video with Brady soon. Was how much does a thought weigh? Or do you get heavier when you learn stuff? Because information and entropy are linked. Thunder's talked about thermodynamics. He knows as well as I do that entropy and free energy are linked. And free energy and mass, of course, or energy and mass are, of course, linked. So there's an interesting set of discussions that could be had.
This is a game for children. The dendritic extensions are going to weigh more than any of your little wavy particle-y crap. Oh.
Okay, well, I would look forward to that. I'll say goodnight. What it
basically boils down to is neurochemistry, right? That's where neuroanatomy. Neurochemistry. It's not stored in the
neuroanatomy.
It's in the
physical
neurochemistry.
rewiring.
Anyway,
I do have to go. Good night, everyone.
I feel like a terrible parent. I feel like a terrible parent that's got to tell his children to calm down. We're all going to bed now. Okay.
I am exactly. It's 2 minutes past midnight.
But I have to say I've absolutely loved this show. I think it's been absolutely fantastic. And
let me just add one point, which I've been sort of, all this stuff about the, the quantum mechanics and this experiment, that experiment. For the large point, this is what we were talking about earlier. It's areas of applicability, and The most quantum relevant substance you or I will ever come across is water, where 50% of the atoms are hydrogen. Sorry, 2/3 of the atoms are hydrogen, right? That's one proton and one electron. It's the most quantum chemical you will ever come across. And even that, you can get a pretty reasonable Newtonian model that will accurately measure water, right? And at that point, why are you so virtually everything that you experience in real life can be modeled with Newtonian mechanics?
Yeah, in terms of
I'm
molecular
sure.
dynamics.
Yeah,
Yeah,
exactly.
absolutely. Yeah, no, there's an awful lot to be said for that. But on the other hand, some of those molecular dynamics force fields, you have to go back to where do they come from? Well, in often cases, they come back from, quantum full density functional theory calculations. We could get very technical here. It's a bit late to get technical. I do take your point, Thunder.
Just
but,
so we're clear, I measure the neutron scattering that parameterizes those things.
Yeah, no, we do a lot of
measure where the nuclei are, and you've got a good start.
Yeah, knowing where the electron density is helps as well, though.
Nope.
Oh,
nuclei.
stop it.
Stop
It.
Well,
No,
okay.
stop it,
This is going to break
boys.
out into a fist fight, so I'm going to go
Stop
now.
it, boys. You're
night.
Gonna go. See you later. Been a pleasure.
No, I'm going to
pleasure.
stop this. Come on. It's been great fun. Thank you all very much.
They've all gone. DPR.
they
Everyone's
have.
gone apart from Hogtie.
They have, but we're still
I
broadcasting.
was the first one to leave. I was going to leave.
Yeah, well, there you go. You see, you should have been better to be a quitter.